So here in this problem, we are being provided with the equation of three lines. We have x minus y minus 6 equals to 0. We have 4x minus 3y minus 20 equals to 0. And 6x plus 5y plus 8 equals to 0. And we need to show that these three lines are concurrent. And also, we need to find out their common point of intersection. Okay, let us begin. So first, what we'll do, we're going to name each of the three equations. So let's say L1 represents the equation of the line x minus y minus 6 equals to 0. We're going to label this as number 1. Then we have line 2. Let's say line 2 is denoted by the equation 4x minus 3y minus 20 equals to 0. Let's label this as number 2. And then we have the third line L3. L3 is given by 6x plus 5y plus 8 equals to 0. So this is our third equation of the line. Now, in order to show that they are concurrent, concurrent simply means that the three lines are going to pass through a single point. So what we'll do, we're going to solve equation number 1 and equation number 2. We're going to find out the value of x and y. So solving 1 and 2, and the value of x and y that we get is actually going to be the common intersection point of line L1 and L2. So let's do that first. So we're going to solving equation 1 and 2. So here, what we can do, we can take equation number 1 and we're going to multiply throughout with 3. That means we're going to multiply each terms with 3. So that makes it 3x minus 3y minus 18 equals to 0. Then we take equation number 2. We're going to keep it as it is. The equation number 2 is given by, we have 4x minus 3y minus 20 equals to 0. Now let's do one thing. Let's subtract each of the two equations. Now when we subtract, so we have 3x minus 4x, that makes it negative x. So negative 3y minus negative 3y, that gets cancelled out. Then we have negative 18 minus negative 20, so that makes it positive 2. The positive 2 equals to 0, which means that solving for x, we get x equals to 2. Now, in order to find out the value of y, so we can substitute x with 2 in either equation 1 or 2. So let's go with equation number 1. That's a simple one. So equation number 1 gives us, we have 2 minus y minus 6 equals to 0. So we have negative y minus 4 equals to 0, which means that y is going to be negative 4. So now we have found out the value of x and y. So here we can say that x comma y, or we can say the point 2 comma negative 4, that is going to be the common point of intersection of line L1 and L2. Now, since the line because we want to show that these three lines are concurrent, it must be true that the line L3 must also pass through this point 2 comma negative 4. That means it must satisfy the equation of 3. Now, in order for the line L3 to be concurrent with L1 and L2, it must also pass through the point 2 comma negative 4. So what we'll do, we'll take equation number 3 and we're going to substitute x with 2 and y with negative 4, and let's see if it satisfies the equation. So here we have 6 multiplied to 2 added to 5 multiplied to negative 4 plus 8. So let's compute this value. So 6 times 2, that's positive 12. 5 times negative 4, that's negative 20 added to 8. Now we have 12 added to 8, that's positive 20, and we have negative 20. So that's definitely going to give us 0, which means that it is satisfying the equation of the line L3. So this means that this only tells us that hence the three lines L1, L2 and L3 are concurrent, hence proved. And in this problem, we were also asked to find out the common point of intersection. We have already found out the common point of intersection is going to be 2 comma negative 4.